In this example, we're given a model for describing the price of a car between the years 2005 and 2015. Now, I noticed that this model is quadratic, meaning it has a squared term, but since there is no single t, just t squared, we should be able to solve this problem using square roots like we did with our falling object problem. So let's go ahead and do that. In this example, we want to know what year was our average car costing us $22,500. So since that's the C value, I'll go ahead and just plug that in for C right here. So I'll start with that. So 22,500, I'll just replace that with C equals, and then there's my equation. So because, like we said, there's no T term in here, we should just be able to solve this using square roots like you'd solve any old equation. So let's go ahead and subtract 15,000 from both sides. I'm left with 7,500 is equal to 90.5 times t squared. I still want to continue trying to get that t squared alone, just like if it was a t variable, I'd want to get that by itself. So next up, let's go ahead and divide by 90.5. And when I do that, I'm going to round that answer off. Although in the calculator, I'm going to leave my full answer to be as accurate as possible. But on paper, I'm going to write down it's about 82.87 equals t squared. And so now that the t squared is by itself, now I can go ahead and take a square root. And like I said, I've left this full number in my calculator so I can be as accurate as possible. When I take the square root of that, t comes out to be approximately 9.1 if I round that off. And then just to make sure that I'm answering their question, let's go back and see what it was again. They said during which year was the average price 22,500. So this must be about 9.1 years since when this problem began. That was 2005, they told me. So I would just do that as the answer. It's about 9.1 years since 2005. If you want to go ahead and actually add that up, you can say it's 2014, maybe a little bit into that year 2014.